All right, guys, we are going to do our note 6 for this unit 5. It's on multiplying monomials by polynomials. Okay, so remember our rules of exponents. When we multiply like bases, we add the exponents, such as d to the 4th times d to the 3rd. We're going to add the 4 and 3, so we get d to the 7th. Power of a power, we multiply the exponents, so that's like m to the 3rd squared. We're going to multiply the 3 and the 2, so we get m to the 9th. Zero exponents is always 1, so remember if we have a whole bunch of stuff to the 0 power, it turns to 1. Or if we have just parts that go, just the y is going to go to 1, so we get x to the 3rd, z to the 4th. Okay, so distributive property lets you multiply a sum by multiplying each term separately and then adding the products. Then we have here using the distributive property, distribute the monomial to each term in the polynomial, multiply each pair of monomials, combine like terms, and put your answer in standard form. Remember, standard form is descending order of those exponents. All right, take a moment to write this stuff down. All right, let's move on. Okay, so what it says we need to do is we're going to take each monomial times the part inside. Okay, so I'm going to take negative 2x squared times 3x squared. I'm going to take negative 2x squared times negative 7x. And I'm going to take negative 2x squared times 10. So I'm distributing it so it gets multiplied by each monomial part. Then it's just taking a look at each of these and going ahead and doing those. And we've done monomials times monomials. We multiply our coefficients, so we get negative 6, and then we are going to add the exponents, so x to the 4th. Okay, now I'm going to look here. Negative 2 times negative 7 turns into a positive 14. I'm going to add my exponents. Now this x, remember, has a 1 exponent, so we get x to the 3rd. And then my last part, negative 2 times 10 gives me negative 20. And then I just have my x squared. Last thing I want to check to make sure that it's in descending order. So I see that my exponents all go down in order. So this is going to be my solution. All right, let's go ahead and take a look at the next problem. So I'm going to make some space here for us. All right, so 5a squared gets times the first term of negative 4a squared. Okay, 5a squared gets times 2a, and that 5 is positive, so I'm going to write a plus here. 5a squared times 2a. Okay, and then I'm going to take that 5a squared times the negative 7. Okay, so we're going to take care of multiplying each term. All right, so we take our coefficients. 5 times negative 4 gives us negative 20. I'm going to add my exponents, a to the 4th. Okay, now my next two. 5 times 2 gives me 10. My exponents, squared and 1 gives me a to the 3rd. Okay, and then my last two terms, 5 times negative 7 gives me negative 35. And then I just have my a squared. All right, so take a look. My exponents are in descending order, so then my solution. All right. Okay, so these two problems here are going to be just the same as the last page. So I'm going to go ahead and I'll get this one started for you. Now some of you are going to be able to look at this and not need to write out every term times every term, and that's just fine. You can go ahead and skip that, but I'm going to write it out so you can see where it comes from. So 6y times 4y squared. Remember this, it's a positive. Okay, so now I'm going to take positive 6y times negative 9y. Then I'm going to take positive 6y times negative 7. Okay, so I'm just going to write out what we should look at for that one. And I want you guys to go ahead and work on that one on your own. Okay, and here comes the answer. All right, take a look there. How did you do? Check your multiplication of your coefficients. Make sure you add your exponents. All right, go ahead and I want you to try number 4. So give number 4 a try. Okay, how did you do on writing that out? If you didn't get that, go ahead and make the tweak now. Okay, here comes the answer. Okay, taking a look here. When I multiplied those, I got to my second step and I saw that my exponents went 3, 4, 2. Remember that our answer needs to be in descending order. Oops. So to be in descending order, that needs to be a 4 there. All right, so now my exponents go 4, 3, 2, so they descend. All right, these next problems on the back, I'm going to just show you guys. These ones are going to be a little bit different than the last ones. We'll take a look here. Here we're going to have 2 polynomials that we're distributing to. Okay, so then we get to adding your like polynomials. Don't worry about writing this down. You still follow the same idea. Okay, so let's go ahead and take a look at 5. So in 5, you'll notice that we have a 4 that's getting distributed here and here. So we have 4 times 3d squared plus 4 times 5d. Okay, then in my second part, I have a negative d that's getting distributed here. So negative d times d squared, negative d times negative 7d, and negative d times 12. Okay, so the red is from the first monomial times polynomial, and the black comes from the second one, but we're going to do it all out into one step. So 4 times 3d squared gives us 12d squared. My next term, 4 times 5d, we get 20d. All right, negative d, remember that has a 1 power, times d squared, we get negative d to the third. Okay, remember these both have 1 powers. So negative d times negative 7 turns into a positive 7 d squared. Then we have negative d times 12, which gives us negative 12d. Now we look here for any like terms, and we want to be writing it in standard form. So highest exponent first. So I have my highest exponent of negative d to the third. Then I have squared exponents. So a positive 12 and a positive 7 gives me positive 19 d squared. Okay, and then my last two, 20d and negative 12d, gives me an 8d. Now my exponents go in descending order, so that makes this in standard form. All right, take a minute to get that down if you haven't done so yet. All right, let's take a look at problem 6 here then. The first one, we're just going to multiply a 3 to everything. So actually, I'm just going to do that multiplication straight out for you and not write it out individually. So 3 times 5x squared gives me 15x squared. 3 times 2x gives me 6x. And 3 times negative 4 gives me negative 12. First one, distributed. All right, now I'm going to take my negative x times 7x squared. So I get negative 7x. Remember, this is a 1 power, so x to the third. Negative x times 2x gives me negative 2x squared. And then negative x times negative 3, negative times negative turns into a positive 3x. Oops, moved a little there. All right, so now we're looking for highest power first. So that would put that as my negative 7x to the third. Okay, then my next powers are squareds. So 15x squared minus 2x squared, so plus 13x squared. I don't do anything with the exponents. All right, then I have 6x, a positive 6x, and a positive 3x. So that gives me 9x. And then my last term, don't lose that negative, is negative 12. My exponents descend 3, 2, 1, and a 0 exponent, and that gives me my finished completed product. Okay, take some time to do problem 7. Take some time to do problem 7. Okay, I'm going to take a moment here and I'm going to rewrite it all out where I have the terms multiplied for you. All right, check with that match there and see if you agree with it. And multiply those through, and then in just a moment, you're going to see the answer. All right, notice with this one that the negative 12t and the positive 12t are going to cancel, and so we're ending up with 18t squared minus 45 for our solution. All right, let's move on to the next problem. Give this one a try all on your own. Again, if you don't want to multiply it all out by the showing on each term, you don't have to. You can just jump right to what it's multiplied to. All right, here we go. All right, take a peek. We only had two like terms here, the 4x and the 14x. So that gave us 3x squared plus 18x minus 6. Descending order, exponents highest to lowest. All right, let's move on to some of your favorite word problems. All right, ladies and gentlemen, with this one we are going to use a system to get us started. Greg pays a fee of $20 a month for local calls. Long distance rates are 6 cents per minute for in-state calls and 5 cents per minute for out-of-state calls. Suppose Greg makes 300 minutes of long distance calls in January. M of those minutes are in-state calls. Find an expression for Greg's phone bill for January. Okay, so for his bill, he pays, so B let's have for bill, he pays $20 a month for local calls. Doesn't matter how many minutes. So he already has that $20 flat fee. Plus, he's going to pay 6 cents per minute for in-state calls, plus 5 cents a minute for out-of-state calls. But these two here, in-state and out-state, are a little bit different, so we need to decipher that. It says, suppose Greg makes 300 minutes of long-distance calls in January. So that's in-state plus out-of-state equals 300. And M of those minutes are in-state calls. All right, so we can either solve for in-state or we can solve for out-of-state calls so that we can replace either our in-state minutes or our out-of-state minutes. Let's go ahead and solve for our out-of-state calls. So I'm going to subtract by M. So my out-of-state calls is 300 minutes minus M. This is going to replace there. So my bill is at $20 plus 6 cents per minute of in-state. Remember, M is for in-state calls. Plus 0.05 times 300 minus M. Okay, so I'm replacing this out-of-state M with this information here because that's how many out-of-state calls I have. All right, so we're going to distribute there. So I get B equals 20 plus 0.06 M. Haven't changed anything there. We get 300 times our 0.5, which gives us 15 minus 0.05 M. We have some like terms and some like terms. Let's go ahead and combine those. So we have 35 plus 0.01 m. That's how much his cost for his bill will be dependent on his in-state calls. We can talk about this one tomorrow too if you guys are having some questions. All right, a parking garage charges $30 per month plus 50 cents per day, daytime hour, and 25 cents per those hours during nights and weekends. Suppose Joanna parks in the garage for 47 hours in January. Each of those are night and weekend hours. Find an expression for her bill in January. Okay, so just like the phone one, she was charged that $20 flat fee. Here she gets charged a $30 flat fee. Plus 50 cents per daytime hour. Do we know how many daytime hours she has? Each of those are nights and weekends, 47 total. Okay, so if we have 47 total, daytime, okay, so she has a total of 47 hours. So that's her daytime plus her nights and weekends. Okay, we know H represents nights and weekends. For 47 is D plus H. H represents nights and weekends. Okay, so let's go ahead and solve for D so we can put it here for our daytime hours. So we're going to minus H to both sides. So D equals 47 minus H. This is now going to be for our daytime minus H. Okay, plus our 25 cents per H night hours. Okay, so we're going to distribute here. So 30 plus, we have our 0.5 times 47, which gives us 23.5, minus 0.5h plus 0.25h. All right, like terms here, we end up with 53.5. Okay, now remember, this is a negative 0.5 plus a positive 0.25. So it gives us a negative 0.25h. All right, guys, you have your worksheet to be working on for the remainder of the hour. Please make sure that you're respectful and that you get your work done. I expect you to come with that done tomorrow. We'll see you then. Oh, not tomorrow. I'm sorry, you're not here tomorrow and Friday. Monday. So get it worked on now so that you don't have homework over your weekend. All right, see you guys then.